I have a master's degree in the electronic health record, and yet when EHR salespeople start throwing around jargon and telling how wonderful theirs is, I also feel confused. But we don't have to be confused. An EHR is just a machine. You don't have to understand every little detail to know how to use your car, and you don't need every detail to use your EHR. But you do need to have some idea how it works, especially when you're getting ready to buy a new one. An EHR has three main parts: the user interface, the EHR engine, and the clinical database. We use a car to get from point A to point B. We providers use an EHR to get from A to B in the job of evaluating and treating a patient. I'm going to use providers as the example in this presentation because it's what I know. But the fact is, nearly all employees at Connections AZ use the EHR in some way to do their jobs. Obviously, all of us need to see old info about the patient, and we need to capture the new info. This is what EHRs do now, and it's all they do now. But in the near future, they'll do more. We'll come back to these in a few minutes. The clinical database stores all that patient information. The information has to be logically organized, structured, and correct. This is an old-school database. Now, obviously, your clinical database is critical information to your organization. It must be backed up continuously in 3 separate physical locations. It must be written into all contracts who owns this data, you, the user. And you must have this diagram for that database so that you can manipulate it, query it, do meaningful statistics and quality control with it. OpenMRS, by the way, is an open source clinical database. It's especially used in third world countries. It's well designed and allows as much detail as desired to be added to a patient record. Now, by detail, I mean information at the level of concepts. At Connections AZ, we're currently using concepts only for diagnoses, medications, demographics, and billing codes. We're using text blobs for most everything else. Text blobs are the best we can do right now, but they're not very useful for doing quality control or statistical analysis. They're also not very useful for decision support. The user interface is critical too. All of us learned as teenagers how to work a car's user interface. We have only to think, go there, and our brain sends out just the right messages through our hands and feet to the car's user interface. We have formed an internal model for controlling a car. When you get into the driver's seat, you automatically load that model into your working memory. And most importantly, the car's user interface actually matches your own working memory model. With an EHR, not so much. The EHR has a model, and the human user has a model, and the two models have very little in common. Wouldn't it be cool if the two models matched in every detail? Wouldn't your job be easier, faster, and less work? Dr. Riddle and his team recently created the CAZ Psych Eval, which is a great improvement over the previous user interface for providers. It conforms better to how our brains think about the job of seeing a patient, while at the same time having to meet all the billing and regulatory requirements. The fact is, EHR companies don't know our mental workflow and can't create excellent user interfaces for us. Therefore, we must create our own, and the EHR companies, must allow and even encourage this. The EHR engine is the central executive of the EHR. It interacts with a clinical database, the user interface, and any outside systems such as HIE, health information exchanges, and knowledge engines. It must be modular, and actually all parts of the EHR must be modular and interoperable, but the engine above all. It must use standards. This means that the various parts of the EHR are built to be plug and play. If somebody builds a better clinical database, just buy the new one, port your data into it, and plug it into your EHR. Somebody comes out with a great psychiatric knowledge engine, Just buy a subscription to it and plug it into your EHR engine and you're set to go. Now let's talk about the future. If we don't want to replace our new EHR again in 3 to 5 years, we must consider what's going to happen with AI. The first step down the road of AI is the expert system. What does an expert system EHR do? In short, it's like having an assistant looking over your shoulder as you work. This assistant understands your job completely, and he even knows more about psychiatry than you do. Therefore, he can constantly give you advice, search for lab results before you realize you need them, suggest you ask the patient particular questions, give you the current differential diagnosis, suggest particular meds and doses, and so on. By the way, what I'm talking about right here is entirely possible with today's technology right now. It's just that nobody has done it yet. It only lacks the doing. Eventually, AI in medicine, who knows what it's going to look like. But the next 30 years at least will be the age of expert systems. To reiterate, an expert system is a system that helps a human expert do some task. It does this by knowing the human user's mental workflow and knowledge. It helps the user stay on task, mitigates interruptions, provides decision support and suggestions. Current EHRs are nothing like expert systems. So, there are certain things we know we need in an EHR. It must allow sending prescriptions and putting in orders. It must allow free communication between all Connections AZ clinics and facilities. Beyond those requirements, we need it to be as open, modular, and interchangeable as possible. If it is, then it's already set up to transition to becoming an expert system. It should use all the relevant standards. Its clinical database should belong to the user and be open to the user for queries. And it should make it easy for users to create their own modules and user interfaces.